Okay, so as promised, here's video about doing. It's going to be assigned as a pre-lab, but it's the first part of the DC circuits lab, so we can save some time. Now, I completely recreated it. Remember, well, you may not remember if you weren't in that particular class, but there was something tainted I discovered with this once on design that I was working on, so I made one from scratch, and it seems to be behaving. So I've got the 2 voltmeters, I've got the 10K and the 10 meg connected as so, and then I have a 500 ohm, 1.5 ohm or 1500 ohm, 1.5K or 1500 ohm, and I have 15,000 ohm or 15K. So notice how the breadboard works. I've got all the resistors attached to ground, to the black. They're all connected together, back to the power supply, and to the black leads of the voltmeters. And that's okay. They won't interfere with each other as long as I'm careful when I connect these other wires. So let's start off with the 500 ohm resistor. So I want to connect from here to here to start with. And so let's pay attention to what we have here. When I turn on the power supply, we're going to see that power is going to come out, current's going to come out of the power supply into the ammeter, because it's current through, voltage across, then out of the ammeter to the breadboard, and all these pins are connected together. Then it's going to come across here to this resistor, our 500 ohm resistor, and then it's going to make its way back to the power supply. So we want to first, this is our analog voltmeter here on the left. So the first thing I want to do is take a measurement with the analog voltmeter. And so I start the sim, and I see that I have 5 volts and 10.5 milliamps. And I've also got the spreadsheet going on. Isn't that interesting? I don't know what that's all about. Nice. So now this is going to, oh, there it is. Oh, well, maybe if I go to my logbook and write this down, the values I see, and then, oh, look, I can cheat a little bit, because I can use, I'm not using Zoom, so I don't have a whiteboard running, so I can't write on top of everything like I might do during a Zoom session. So I'm just going to go to my logbook and write them down, and I'm going to maybe when I stop the simulation. So this is the first resistor. So and this is the analog. So we have I analog, and which is 10.5 milliamps, and then V analog is 5.00 volts. Okay, so let's see what happens when I stop the simulation. So that's interesting. And I am not quite sure what to do. Let's see if I can oh, doesn't seem to even be there. Make a copy. Let's try one more time. Select. Okay. Well, let's just hope. Because apparently, okay, there we go. All right, so the I analog is 10.5, but it's milliamps, so I do E minus 3 because I want it to be amps. And when you read a digital meter, that doesn't matter. That's why you have NA. Well, I don't know. Let's worry about this a little bit at a time. You take half of the next digit, so that would be plus minus 0.005 E minus 3. There we go. And because it would be, you see it's 0.5, so I want a half of the next digit. And that's what this would be. Okay, and the V analog is 5.00. And then that's 0.005. And the units are volts. Okay, got that. And the nominal value is 500 ohms. Okay. So then let's go back to the design here. So now we want to use the digital voltmeter. Now notice why we've done things the way we have. This way we're not deleting whole pieces of wire and long pieces of wire with the bends and such. Everything stays connected except just a couple things we put onto the breadboard. Okay, let's start the simulation. And now I see 10.0 milliamps, but I still see 5.00. So this is I digital. So already we see something going on. And V digital, and so that's going to be 5.00 volts again. So we'll stop the simulation and we'll go to our spreadsheet, and let's see, we want that has 2 decimal places to match up with the meters. And so this is 10.0 E minus 5. And so let's be careful here because this has to be 3 sig figs. This has to be 3 sig figs. And this is just interesting. I'm not sure in that case, but I'll stick with it. And this is again 5.00, and I have to add units. Did decimal places 0.005 and volts, and this is amps, and of course this is ohms, and this is ohms. And so what we're doing, part of what we're doing here is to verify Ohm's law, which says that I equals V over R is the general expression for Ohm's law. And well, I don't know. Well, I can just put it here. I equals capital V divided by R. And we're going to rearrange that to be R equals V over I. Okay, so this equals V divided by I, enter, and the error we have to calculate, and we'll just, I thought, for the life of me, I can't remember anymore. Let's see, fractional error equals the plus minus divided by the value itself. And so we'll do this here. Oops, too far. Well, let's have to hit the undo key. And so now we have fractional error. Okay. So, excuse me. Well, we can, fractional errors are a little bit easier than plus minus error. So the way this is done is it's sort of like Pythagorean theorem, and where you have the two sides that are at right angles to each other. How do you calculate the last one? Now let's see, is there any way of writing on this screen? It doesn't look like it, so I will, let's see what I can do. I can, oh yeah, I got it. Snip, and can I do that? Can I write on it? Yes, I can. There it is. Okay, so I just want to make it, medium point. Let's make it thick point. Let's see what that does. Wherever it went, I don't know where it went. And because I have a black pen. Okay, there it is. Okay, so what we have is we have the fractional error. Whoops. Fractional error is equal to the plus minus error divided by the value. So for example, this is the plus minus, so we have plus minus I over I is the fractional error, and that's sometimes written like this lowercase delta. So to get the fractional error on R, and we'll talk about this some more in class, is equal to fractional error of R equals fractional error of I plus fractional error on V, and then we just take the square root of it to get the answer, the final answer. I squared plus V squared, and then we take the square root. Oops, 1/2. And let's see if we edit, copy, and we can see if we can, smoking, huh? Okay, so this equals SQRT of this squared, excuse me, plus this squared. And I hit enter. Whoa. And that's pretty small. And let's see, first of all, let's format that to be a plain number. Where is it? I want 2 decimal places. Well, I'll just put that like that for the moment. And then I can, let's think about this. That's a good question. Well, we have to do the number of sig figs. So 3, 3. So this can only have 3 sig figs. Yeah. Okay. And then this is, well, that's fractional error, so we have to be careful. And let's see, we'll make that scientific for the time being. So if fractional error is the value, I mean the plus minus divided by the value, if we multiply the fractional error by the value, we'll get the plus minus error. So it's equal to the fractional error in R times the value of R, enter, and let's make this a number, and 0.53. So that is pretty darn good, actually, plus minus. So this, just so you understand what's going on here. That's the plus minus. Reiterate it. Okay, so you just march on down and keep doing that. So now we want to measure the next resistor. So let's see, first of all, we don't want that one because we'll start with analog. And we'll just move this over here. And we make a connection like that. Now we're ready to measure that one. And let's see. Interesting. Interesting amundo, huh? Oops. And so it still says 5 volts. And okay, so 5 volts and 3.83. So that's 5.00. And and 2.83 E minus 3 and 5.00. And so I leave the rest to you. Good luck.